Overall functional and application description of ESDVs and SDVs. Emergency shutdown valves, ESDVs. Function: emergency shutdown valves, ESDVs, are critical safety devices used to isolate sections of an oil and gas facility during emergency situations to prevent the release of hazardous fluids. They are designed to close automatically upon receiving a signal from the emergency shutdown ESD system. Application: ESDVs are used in various locations within upstream oil and gas facilities, such as on pipelines, process vessels, and wellheads. Their primary purpose is to shut off the flow of hydrocarbons to prevent accidents, fires, or explosions. Shutdown valves. Function: shutdown valves, SDVs, are used to isolate specific sections of a process or equipment for maintenance, testing, or during abnormal operating conditions. They can be operated manually or automatically. Application: SDVs are typically used in process lines, utility systems, and equipment isolation points to ensure safety and facilitate maintenance without disrupting the entire process. Primary use: ESDVs prevent the release of hydrocarbons during emergency situations. SDVs isolate specific sections for maintenance or in response to abnormal conditions. Design and selection criteria. Valve design: 1 body and bonnet. Material: carbon steel, stainless steel, or alloy steels, such as Inconel, depending on fluid composition and operating conditions. Pressure rating: typically designed to handle medium to high pressures, often adhering to standards like ANSI ASME B16.44. Temperature rating: suitable for the operational temperature range of the facility. 2. Trim: material: corrosion-resistant materials such as stainless steel, Hastalloy, or other alloys to withstand the corrosive nature of crude oil and process gas. Design: trim parts, seat, disc, stem should ensure tight shutoff and durability under frequent operation. 3. Sealing: gaskets and seals, materials compatible to fluids such as Viton, PTFE, or graphite, ensuring leak-free performance. Instrumentation parts: 1 limit switches. Function: indicate the open or closed position of the valve. Selection: explosion-proof and weatherproof models to ensure reliable operation in harsh environments. 2. Solenoid valves. Function: control the actuation of the valve, open-close, by converting electrical signals to pneumatic or hydraulic actions. Selection: material: compatible with the process fluid. Design: explosion-proof and suitable for the facility's hazardous area classification. Actuators: type: pneumatic, hydraulic, or electric, depending on the control system and power availability. Design: fast-acting, reliable, and suitable for the operational pressure and environmental conditions. 4. Positioners. Function: ensure accurate valve positioning for control applications. Selection: digital or analog, compatible with the control system, and capable of handling the operational environment. Considerations for medium and high-pressure scenarios. Valve sizing: ensure the valve size matches the pipeline and process requirements to minimize pressure drops and ensure proper isolation. Pressure relief: incorporate pressure relief mechanisms to handle unexpected pressure surges and prevent valve damage. Redundancy: in critical applications, use redundant valves or systems to ensure safety and reliability. Safety integrity level: select valves and components that meet the required seal for the specific application, ensuring compliance with safety standards. Conclusion: selecting and designing ESDVs and SDVs for upstream oil and gas facilities involves considering the fluid properties, operating pressures, and environmental conditions. Ensuring the right materials, robust construction, and reliable instrumentation are crucial for maintaining safety and operational efficiency in these facilities. Technical specification for ESDVs and SDVs. General: design life. Valves shall be designed for a 25-year lifespan. Complete assembly. The actuated on-off ESDVBDV valves shall be supplied as complete assemblies, including the valve, actuator, and accessories. Valve type. Ball-type valves with air actuators shall be used, with trunnion-mounted or floating ball types selected based on pressure rating and size. Hand wheels, not permitted for ESDVBDV, allowed for on-off valves. Seat tightness must meet the specified bubble tight, Class X according to API 590H, API 60 MSS SP61. Fire-safe design. must comply with API 6F8, API 607, or BSEN 12266. Sour service compatibility, compliant with NACE MR1075 PIS-056. Safety integrity level, SIL certified according to IEC 61508. Actuator compatibility, ensure compatibility of actuator with valve in all respects, mechanical torque, etc. Lifting lugs, required on all valves including actuators exceeding 300 kg. Valve body general, flanged end connections, ASME B16.5. Face-to-face dimensions, ASME B16.10. Body construction, split type as per API 6D. Pressure ratings, must align with associated pipe rating. Fire testing certification, API 607. Anti-static and fire-safe design, all valves must be certified fire-tested per API 67 and be anti-static. Materials, material selection. All materials shall be new and free of defects. Valve materials should be selected to minimize corrosion from process and environmental conditions. Compliance. All process-wetted materials must comply with NACE STD-MR01-075. External components. Materials exposed to the environment must be non-corroding to meet site design and data conditions. Prohibited materials. Cadmium plating or galvanizing is not allowed. Bolting must adhere to the applicable data sheets. NDE requirements. Extent, methods, and acceptance criteria must be specified in the specification for piping valves. Valve seat leakage. Maximum allowable leakage must be specified on the valve data sheets. Leakage class VSSO per FCI 72. Actuator general, type, pneumatic piston spring return quarter turn type. Construction material, carbon steel for diameters 2-inch and above, aluminum for smaller sizes due to weight support considerations. Operating conditions, must shut off against the maximum differential pressure and be suitable for open, unprotected environments. Weatherproof standard, IP66 minimum. Tubing and fittings, must be SS36NL with a minimum size of 1/2 inch OD. Fittings should be of Hoke Gyrolock double compression type. Fireproofing, critical valves must be fireproof protected with KMAS. Torque thrust characteristics. Compatibility, must match valve's torque thrust characteristics, verified through actual tests. Valve reseating torque, not less than the breakout torque from the closed position. Stroking time, capable of a stroking time of 1-inch second of nominal bore size against maximum differential pressure. Actuator sizing basis, safety factor, must deliver twice the required valve torque thrust for ESDV, BDV applications, ensuring sufficient power to operate the valve under maximum differential pressures. For on-off applications, a minimum of 1.5 times the calculated force is required. Operating range, must maintain torque margin over the normal range of operating pressures. Calculation data. Required data. Suppliers must provide detailed calculation data including valve breakout torque, running torque, reseat torque, stem maximum allowable torque, actuator sizing, fatigue life, and MTBF, mean time between failure. Actuator mechanical design, orientation and position. Operation should not be affected by actuator orientation. Component strength must withstand maximum operational loads. Compatibility, ensure mechanical compatibility and suitable coupling support brackets. Actuator valve interface, mechanical compatibility, must ensure the actuator is fully compatible with the valve regarding torque, thrust figures, and mechanical stresses. Support brackets. Additional support brackets must be designed to support the actuator's weight on the valve body. Secure assembly. The assembly mounting must be capable of withstanding stresses from valve and actuator movement. Shutdown boxes. Components, solenoid valves, reset and local trip buttons, filter regulators, speed control valves, bypass valves, pilot valves, pressure gauges, and necessary tubing and fittings. Ingress protection, IP66. Material, heavy-duty SS36L enclosure. Cable entries, 4 ISO M20 by 1.5 cable entries. Mounting, must be mounted at an accessible location on the actuator. Filter regulators, type self-draining automatic SS316L with a 40mm filter element. Air filters, must have an automatic water drain and a 25mm mesh size. Limit switches, type Must operate on the proximity principle per DIN 19234 SPDT switches, intrinsically safe EEXIA. Enclosure, protection box with EEXE certified junction box. Indication, must indicate open-close positions and be connected to the PCS for operational monitoring with alarms. Solenoid valves. Type, 3-port changeover spring return type, SS316 body and trim. Operation, normally energized to open, fail close for ESDV, normally energized to close, fail open for BDV. Coil, 24 VDC, insulation class H, weatherproof IP66. Fail-safe design, must provide tight shutoff TSO feature and be certified for hazardous areas. Hand wheels, operating torque, not to exceed 80 nm. Type, yoke-mounted, non-declutchable except for butterfly valves, which should be shaft-mounted. Pressure gauges, specifications. Stainless steel case, Monell-Borden, 6 inches dial, NACE compliant, plus 2% accuracy at half range, glycerine filled. Process connection, 1/2 inch NPT-M, bottom. Local position indicator, type, mechanical, robust, beacon preferred. Mechanical stops, adjustment, externally adjustable for opening and closing strokes, independent of valve travel stops. Speed control facilities, control, needle valves with vernier scales indicating closure times. Tubing, sized for stroking times and pressure ratings. Partial stroke test device, PST. Requirement, field-proven, SIL 3 certified, connected to PCS. Diagnostics, internal checks, spurious trip protection. Operation, 4 to 20 mA DC control signal from PCS. Features, warning of maintenance operator, load factor, air leakage, breakaway pressure, fault detection, dynamic valve torque, and valve stuck alert. Paint standard, manufacturer's standard corrosion protection. Valve body, painted as per manufacturer's standard. Actuator, painted as per manufacturer's standard. Environmental suitability, suitable for the specified environmental conditions as mentioned in the site design and data conditions. TASH quality assurance inspection and testing quality assurance, compliance with QA/QC requirements as part of the contractor's requisition. Must demonstrate adherence to an internationally recognized quality system. Inspection. Contractor or authorized representatives must have free access to supplier's workshops. Supplier is responsible for all inspection and testing prior to delivery. Inspection Test Plan, ITP. Supplier must include an ITP listing all proposed inspections and tests. Contractor has the right to witness any manufacturing inspection or test. Testing includes dimensional checks, actuator testing, hydrostatic testing on valve and actuator, full functional FAT, and partial stroke function testing. Test equipment must be calibrated and certified. Commissioning and site support. Supplier must identify any special requirements or recommendations for support during commissioning. Final acceptance is subject to a performance test after installation and commissioning at the site. Site support. Supplier must provide details of site support capability and execute all necessary commissioning activities. Packaging, preservation, and preparation for shipment. Nameplate details. Equipment must have a primary nameplate of 316 stainless steel, containing information such as item tag number, manufacturer's name, model type number, serial number, actuator type and speed, pressure rating, valve size, material, flange rating, IP rating, hazardous area classification, action on air supply signal failure, and NACE requirements. Packaging. Supplier is responsible for preparation for shipment, including packing, marking, and transportation, as specified in the commercial section of the ITB.